All right, so we're going to start with, we're going to look here at polynomial division, which I know we've been very excited for. So the first one we're going to look at is division by linear factors, which means that if we get a polynomial, so if px being our polynomial, is divided by a linear factor, ax plus b, until a constant remainder r is obtained, then we have this formula here, px over ax plus b. So this means the polynomial divided by this, ax plus b, equals a quotient plus the remainder divided by this factor here. Now, this is sort of our general rule. We've got here also the polynomial equals the quotient times the divisor, which I didn't say before, ax plus b. At the moment, we have a linear factor that's our divisor, or divisor. Don't know how to say that, plus our remainder. Now, it's important to think, if we're dividing this, if we actually don't end up with a remainder, this divisor is actually one of our factors. We can break the polynomial up and get information about this factor. I don't want to go too much into that. This is the definitions in this section, so I'm going to move straight into the division so we can actually do it. So our example question here, we've got the polynomial, so this would be px, is x to the power of 4, so a polynomial of degree 4 plus 2x squared minus 1 divided by x plus 3. And I've written it in the two different forms with a divide symbol and as a fraction. So what we actually do is we go back to long division, which we probably haven't done for a while. So we've got x plus 3, which is the thing we're dividing, the divisor, and then we put under here, we're going to put x to the 4 plus, now I'm going to just leave a gap there, and then go 2x squared, and then I'm going to leave another gap here, and I'm going to go minus 1. Now, the reason I've left the gap is, and I might even change colours for this, this here is actually 0x. It's just a term we don't have in our polynomial, but we're just going to leave it there because it's going to be handy in a minute. So 0x cubed. I'm going to go back. All right, so the first thing what we've got to do is we've got to consider here this x term. We're going to go, well, x times what is going to give me x to the power of 4? And what we've got here is we've got, well, x times x cubed is going to give me x to the 4. So we go, well, x cubed is going to go here. All right. And so in this space, it then means what we're going to do is we're going to times this x cubed by the x here. So I'm going to do a negative sign here. So x cubed, I will come back to this negative sign in a minute. So x cubed times x gives me x to the 4. And then x cubed times 3 gives me 3x cubed. And we're going to take these off each other. So x to the power of 4 minus x to the power of 4 is 0. 0x cubed plus 3x cubed gives me 3x cubed. All right. So now we've done our first term. We're going to repeat this again. So now we're going to look at our next term here. Now we've got 3x cubed here. And so x times what is going to give me 3x cubed? Well, it's going to be 3x squared. So I'm just going to change colour and I'm going to, maybe I'll use this light green. So here, to get this term beside it, we did x plus 3, which is our divisor, times x cubed, which was the number we got at the top here. Maybe I will use a highlighter. That relates to this one here. And then our next one here, we're going to look at 3x squared. So we're going to have x plus 3, x 3x squared. And so that is going to give us here our next term. So I'm just going to do minus here. And we're going to do 3x squared times x is 3x cubed. And then 3x squared times 3 is plus 9x squared. Now, before I subtract this term from this term, I'm actually going to bring this term down because we've still got this in our polynomial. So this comes down here and we have plus 2x squared. So we're going to have 3x cubed minus I might actually remove that line and put it below. So we've got 3x cubed minus 3x cubed gives us 0. And then we've got 2x squared minus 9x squared gives us negative 7x squared. Okay, so now we're up to our next line. Have I made an error here? I'm just going to keep going. Anyway, so negative. I'm just looking at my working before and I realise I might have made an error. Oh, I have. This should have been negative here. Sorry, so that means that up here this should have been a negative as well, which means in here these would have been negative values. So apologies, I was looking through. All right, now we've fixed that error up. So negative 3x cubed plus 3x cubed gives us 0. 2x squared plus 9x squared gives us 11x squared. Now we're going to go to our next line here, so 9x squared, we're going to look at our term here, x plus 3. What times x times what is going to give me 11x squared, and it's going to be just 11x. And so our next line of working here is going to be, we're going to have plus 11x up here. And that is going to give us 11, take 11x squared, and then 11x times 3 gives us 33x. So plus 33x. And this 0x is going to come down here. So we've got this next one, 11x squared minus 11x squared gives us 0. 0x minus 33x gives us negative 33x. All right, and this negative 1 is going to come down here, so we've got to take 1. All right, so the next step here is x times what is going to give me negative 33x, and that will be negative 33. So then our next step here is to go, well, x plus 3 times negative 33, and that's going to give us our terms below here, which is x times negative 33 is take negative 33x, and then our other term here is going to be negative 99 from these two values here. And so we're going to have here negative 33x plus 33, 0, and then we have negative 1 plus 99 gives us 98, and that is our remainder up here. So at the moment we've got, to bring this back full circle, we're looking for this px over ax plus b. So in this form we had our equation was x to the 4 plus 2x squared minus 1 all over x plus 3. And this equals, if we go back up here, we're going to be looking at our qx, our quotient, so qx plus r over ax plus b. And this is going to be our quotient, is this value we've got up here. So we've got this thing divided by, that gives us x cubed minus 3x squared plus 11x minus 33 all over 98 over our divisor, which was x plus 3. So if you look at this in the whole way, we have our polynomial is this value here. We have our linear factor is this x plus 3, which also appears over here. And then we've also got, let's use this, our quotient is this value here. And our remainder in this specific example is 98, which corresponds to this. All right, so I didn't specify in here, but we've got every time we work out a value, so finding this x value here and going, well, what gives me x plus 4? We went to x3. This is my cubed column. I kept everything sort of in the same column. I know I'm a bit messy and I've gone around the place, but this was the cube, this was the quadratic, this was the linear, and then this was our constant column. Now, I did go a little bit pear-shaped. Now, every time you pull this out, this x cubed, this is purely meaning that because of this value up here, timesing it by this times this is going to give you this value here. So we need to take it away from our polynomial every time. All right, I'm going to leave you with that one. I'll do one for quadratics next, but I'll leave that